So here I selected a few more problems that have to deal with the square roots. And what I did was I picked some unconventional ones. And I just want to make sure that we understand that square roots doesn't always have to be like a perfect square, a whole number. They can be fractions, they can be decimals. This one is a little tricky for some people. And the reason why is because they remember that square roots, I told you, our answer cannot be have a negative in the radicand. But notice the negative is on the outside. When anything is outside the radicand, we can ignore that and just put our finger there to cover that up. So you can do the square root of 4. You know 4 is a perfect square, which is 2 squared. I just want the root, or the base. So this is this. The negative, you're just going to put on the outside. Because remember, this square root can only apply to what's inside. Anything that's on the outside has nothing to do with the square root. So when we talked about your radicand cannot be negative, this is not your radicand. It's outside the radicand. So if I cover up, you can do the square root of 4, which is 2, and then just bring this over. For this guy, you know that I don't have a whole number there. It's 0.25. All these we know are square roots, because you can see there's no number, so it's understood as a square. So these are all square roots. If this decimal point wasn't there, you know that the square root of 25 would be 5 squared. But again, I don't put the exponent, I just put the base down. But I don't have 25, I have 25 hundredths, a decimal point. So now, once we've learned that, you got to figure out what 2 decimal points that will give you 0.25. So you know that it can't be a whole number. Let's try this, 0.5. Remember, 0.5 squared would be 0.5 times 0.5. You can either put this in your calculator, or if you're doing it by hand, you know that 5 times 5 is 25. And then how many digits are behind the decimal point? 1 here, 1 here. So there are 2 numbers behind the decimal point. That means your answer here has to have 2 digits behind the decimal point. So it's not going to be here, because if I put it there, it's only 1 number behind the decimal point. I'm going to have to put it here. See, there's 1, 2. So 0.5 will give us 0.25. So that's the reason why that makes sense. 0.5 times 0.5 will give you 0.25. I know a lot of people will say, no, 0.5 times 0.5 only gives you 2.5. You got to remember, you got to count 1, 2. So our answer has to have 1, 2. Okay? A lot of people think, oh, 1 here, there should only be 1 here. No. When it comes to multiplication, you have to count 1, 2. Keep a running total of how many numbers are behind a decimal point. So the same thing here. We know that the square root of a perfect 9 would be 3. But because it's a decimal point, should it be 0.03 or should it be 0.3? Well, what you should do is secretly square them. If I square this, that would be 0.03 times 0.03, which I know 3 times 3 is 9. But how many digits? 1, 2, 3, 4. 4 digits behind a decimal point. So to make 4 digits behind a decimal point, I'm going to have to add some zeros here. 1, 2, 3, 4. So 0.03 times 0.03 gives me 0.0009. No, I don't have 0009. I just have 0.09. So this can't be it. So then try just doing 0.3 times 0.3 to check it out. 0.3 times 0.3. We know that's 3 times 3 is 9. And then how many digits? 1, 2. So to have 2, you always add zeros in the front because I need to have 2 digits behind the decimal point. Because if I put this 0 in the back, it looks like I have 90. I know 3 times 3 is 9 and not 90. So notice 0.3 is our answer. Because I want the root, this goes away. And we talked about this. The square root of 49 over 9, even though that is a fraction, when you have a fraction, we can square root the top and then square root the bottom as 2 separate problems. So the square root of 49 is 7. The square root of 9 is 3. Now the last thing that we want to talk about was this and this and this is because they're square roots. We know our answer could be a +2 or a -2. So a lot of times you'll see answers with a plus minus in the front. The last thing I wanted to point out, just to re-emphasize, that if you have the square root of -100 is different from the square root of 100 with the negative on the outside. Here, we can't think of two numbers that are the same to give us a -100. Remember, 10 times 10 is 100. -10 times -10 is also 100. There's no two numbers that I can think of that are the same to give me -100. Remember, because this is even, we know that the radicand must be positive. So since it's negative, this would not be real. In other math, you'll call it imaginary. But here, you can do this. Notice that this is a positive. Because this is a positive, even though there's a negative on the outside, you know that you can do the square root of 100 is 10, and then keep the negative separate, so we get -10. That would be it.